Okay, so we are proceeding with sets and grids. Okay, just to emphasize again, this is already done. Gayara completed pretty much everything from this lesson. However, I'm teaching you how to use grids because probably for your O-levels, you haven't learned grids and it was a new thing to me as well. Okay, but let's take an example where there are 100 employees, okay, and 60 of them are males and 50 of them are experienced. Okay, it's a bit of an odd combination, right? So from here we have to derive that there are 40 females and then that there are 50 inexperienced. Okay, it's not given, but you must derive that. Usually they will give 50, like, females and males, so experienced and inexperienced, but this is like a odd combination. However, you can represent it in a Venn diagram, on a Venn diagram this way, right? So you have the boundary here. Okay, you can mark that it's 100 because you are talking about 100 employees. And then you have males and experienced. So this is the experienced. So if I mark this as X, X represents number of experienced males. Okay. This stands for, let's say this is, so since M is 60, this is 60 minus X. And since E is 50, this portion is 50 minus X, and that represents females who are experienced. Okay, this is males who are inexperienced. We will mark that. So this is like experienced females, and this is inexperienced males. Okay. So if I ask you a question, if experienced females the number is 20, how many experienced males are there? Okay, so this is pretty straightforward because the total number of experienced people, total experienced is 50. So therefore, experienced males in this case is 50 minus 20, right? It's 30. So now the question here is not just the experienced males, but I will tweak the question so that it will be a different issue. Okay, so I would ask this question in a different way. I would ask, what is the maximum number of experienced males? Okay, now this is a tweak because it's not like a given number. Now we are looking at a situation where minimums and maximums are used. Okay, so you can see that. So now we are looking for maximum experienced males. Okay, so so the maximum overlap happens when one circle is totally inside the other one. So in this case, if you take a Venn diagram like this, you have one circle and you have another circle inside that. Okay, we will mark this as the male circle, which is 60. All right, and this is the experienced, which is 50. Okay, and from this you should know that the females are outside this. So the total is 100. So the females are outside this circle because they are not males. Whoever who is experienced are embedded in the male circle. Okay, so this is the case of a maximum overlap. Okay, so in this case, the maximum experienced males is 50 and maximum inexperienced females is actually 40. And then in this case, the maximum, the minimum so this corresponds, this maximum number of inexperienced females corresponds to the maximum number of experienced males. Okay, but the minimum number of inexperienced males in this case is actually 10. Okay, yeah, you can move between the experienced males and inexperienced males. Now, if you represent this in a like this is possible to be represented. You can say that, let's say, yeah, sorry, this is actually not like an impossible scenario we will discuss here. Something that's impossible is when, so this is a possibility, okay? This is a possible scenario. And something that is not possible is when you represent males, let's say this is 60, and experienced people who are outside, completely outside. Okay, if this is 60 and this is 50, because the total is 100, you remember that. So in this case, if this is 60, if this is 50, whatever the space that's outside, okay, just for the understanding, I will put this inside the circle. So let's say this is M is 60 and E is 50. Outside, it will be -10. Okay, so that's not possible. So the addition of 3 spaces must be equal. Now compare it with the possible scenario where this space is 50, which is the experienced males. Okay, and 10 is the inexperienced males, and 40 is the inexperienced female. So this is possible, but this is not possible. That means there's a negative number of people who are neither male nor experienced. So this is like the number of inexperienced females is a negative 10. It cannot be the case. Okay. So this is a situation that you need to avoid. And let's say if you change the numbers a bit, okay. Now, let's say the total is still 100, whereas the males are 50. Previously it was 60, now the males are 40. And the experience is 50, again, the same number. Okay, but in this case, that no overlap is a possibility. Okay, because the total is 100, males is 40, experienced is 50, and this is 10. So that means the number of inexperienced females is 10, but all the females are experienced. I mean, all the other females are experienced, means, and all the experienced ones are females, and all the males are inexperienced in this case. Okay. In this case, experienced men equal to 0. Okay. So just be mindful of the representation of these cases. Okay. Now, what we learn here from the grid method provides like a very sort of a mechanical way of doing this. Okay. That's the beauty of the grid method. Now, let's take the case number 1. There, so the grid method goes this way. Okay, so there are males and females. And you have experienced and inexperienced. Okay. The idea is that the total is 100. So the total number of experience per people, we know that is 50. And the one that was given earlier is that the number of males is 60, okay? These were the information given to us at the first place. Now, you can almost mechanically fill this up. See, 50 plus 50 is 100. So that means the total number of inexperienced people are 50. And since this is 60, females constitute of 40 people. Okay, so they add up. And you were given the information that the number of, you remember in the previous case here, this information was given. The number of experienced females was 20, experienced females. If you have this piece of information, the rest you can mechanically add up, okay? So that means inexperienced females is 20. Experienced males are 30, because 30 plus 20 is 50. And the inexperienced males are 30 as well. See, the advantage of the grid method is actually filling up mechanically, okay? However, there's a very low probability of getting it wrong, okay? That's the beauty of it. So in the case of, this is the original example, okay? But if you look at the case of, let's say, the minimum and maximum case, okay? In this case, again, male and, yeah, sorry, male and female, and you have experienced and inexperienced. Okay. So it was given that the number of males is total is 60, and the number of experienced people were 50. Okay. And the other information that was given was that maximum of experienced people are males. Okay. So that means in this case, as long as there are 60 men and 50 experienced people, all of them can be men. So now you can easily, mechanically fill up the rest, okay? This is 50, so this becomes 0. And this is 40, because it's 150, and this becomes 40 again. So just the same thing, but without much of visualization, using the grid method, you can do it, yeah, without much thinking. And the same goes here, okay? The case of minimum. So this is the case of the minimum, the third one is the case of minimum experienced males, okay? So if you do the grid method here, you have males and females, experienced and inexperienced, okay? What you were given is that the number of men were 40, and that the number of experienced people are 50 again. But the original information given was that the minimum number of experienced men. So that means the number of experienced men is actually 0. Okay. So with that, you can mechanically fill up the other information. So if the number of experienced men is 0, it's like a minimum. The number of experienced females is 50. Okay, and then you know that the total is 100. So you fill up 50 here and 60 here. And just to add up, this is 50, then this is 10. And if this is 10, this is 40. Okay. So that's the use of the grid method. I hope you can appreciate that. Nothing new. However, it's like when you are in doubt with the Venn diagram, you can always use the grid method. Okay. And one last thing I want to teach you regarding the Venn diagram is that you see the union. Okay, we have learned that previously we learned that the union between, so let's say if this is A and B, we know that in the probability also we learned that, so if let's say just for the ease of it, we will mark this as A, B, and X, okay? So the union between A and B is actually A plus X plus B, right? So in order to get that, you can take that it's the probability of A plus probability of B. Now, X is double counted in this case. So in this case, you have to deduct the intersection, which is equal to X, okay? Because X is double counted. This means this is A plus X plus B plus X, so that A plus B plus 2X. So that's why we have to deduct. Now, in the case of 3, so let's do an example of 3 cases, okay? So let's say this is an example where there are 30 people who drink tea, 40 people who drink coffee, and 20 people who drink Milo. Okay. Yeah, something like this. But when you actually draw up, okay, we are not dealing with the numbers here. When you draw up this Venn diagram, say I would just try to, yeah, do something like this, right? Let's say this is tea, this is coffee, and this is Milo, okay? So you must understand that now, if you mark each let's say you mark this as T, C, M, and let's say this is let's say something between let's say this is just for the understanding, okay? This is alpha, beta, and gamma, and you will mark this as X, okay? So now you should understand that the union means like all is equal to T plus M plus C plus alpha plus beta plus gamma plus X, okay? So this means this is the category that only one drink. And this is like 2 drinks. People who drink 2 things. And this is the people who drink all 3. Okay, in order to obtain this in the probability sense, right, you have to add up probability of tea plus probability of coffee plus probability of Milo And you should understand here that it's actually triple counted now. Okay. Therefore, you must so you must deduct all these parts. Okay. So let's say the probability of T intersection C, probability of T intersection M, probability of M intersection C. Okay. And the probability of T intersection M intersection C. Okay. So the probability of, so let's check what we wrote. Is it correct? Okay. So the probability of T here, we can mark it as T plus alpha plus X plus beta. And C can be marked as, I will use a different color. It can be marked as C plus beta plus X plus gamma. And M, a different color, I will use it as M plus alpha plus X plus gamma, right? And these things I will mark in a different color altogether. T intersection C, T intersection C. Okay, so we are looking at beta and X. And this is, I'll write it in the like the same line, but you should know that they come in pairs. T intersection M. Okay, so that's alpha and X. And M intersection C, that's X and gamma. And total intersection, that means T intersection M intersection C is X. Okay. You can see now that, look here. So there are two alphas here. So when we want to cancel them out, you will cancel one alpha with an alpha here. Okay. And then you have two betas here, and one beta is canceled out. Okay, we will do that. And the same goes with gamma. Two gammas here, we will cancel one gamma and one gamma here. Now you can see that there are three X's here. So all these are all right. Okay, so you have T and T. You have M and M. And you have C and C. Okay, and you have alpha, beta, and gamma, whereas you have three X's here. but we only need one x, okay? We only need one x. So there is 1, 2, 3, right? So if you actually cancel it out, x is remain as a negative. You see that, but we need a positive x. So rather than deducting everything, like rather than deducting this part, you must actually add. Did you see that? So this is a common pitfall, okay? So the right way to do this is, let's do it in a clearer manner. Now, again, you have 3 sections. Let's try to overlap this as much as possible. Okay. So again, mark it. So this is tea, coffee, and Milo. So you have T, C, T, C, and M. And you have alpha, beta, and gamma, and X, right? So the right way to find the union of this entire thing, okay, union, should be, you know, T plus M plus C plus alpha plus beta plus gamma plus X, right? So to get this one, you have to write probability of T plus the probability of C plus the probability of M plus the probability of T intersection C intersection M, and deduct probability of T intersection C minus T intersection M minus C intersection M. Okay, so again, let's check. All right, so this is T is T plus alpha plus beta plus X. C is C plus alpha plus gamma plus X, and M is M plus beta plus gamma plus X, and this is X. Okay, and T intersection C is alpha plus X. T intersection M is beta plus X, and C intersection M is gamma plus X. Okay, so here now there are 2 alphas, 1 alpha to 1 alpha cancels, and 2 betas, 1 beta to 1 beta cancels, and 2 gammas, so 1 gamma to 1 gamma cancels, and there are 4 x's and 3 x's are cancelled. Okay, 1, 2, 3 with 1, 2, 3. Now you get the remainder, which is T plus alpha plus beta plus C plus gamma plus M plus X. Okay, now this is equal here. M and M, C and C, alpha and alpha, beta and beta, gamma and gamma, and X and X. So you see that there's a difference when you pick 2 cases versus 3 cases. Okay. This is important. Okay, this will be very important. I have seen this being tested in GRE. Just for your understanding. Okay. Yeah, thank you so much. You will see the 3rd lecture on permutations and combinations. Yeah.